What is the value of? We have to simply add up those numbers, and when you do, you get 100. A cube has an edge length of 10. The edge length is increased by 10%. What is the volume of the resulting cube? So we're going from 10 to 11, I guess, when you increase by 10%. And now the volume of a cube is the edge length cubed. So 11 cubed would be the new volume, and 11 to the power of 3, I believe, is 1331. A cylinder has a height of 4. Each of its circular faces has a circumference of 10 pi. What is the volume of the cylinder? All right, so let's just draw a cylinder. And then height is 4, okay. Each of the circular faces has a circumference of 10 pi. So the circumference C is equal to pi times the diameter. So they're saying that circumference is 10 pi. So that means the diameter is 10, and therefore the radius would be 5. Volume of a cylinder is given by the equation pi r squared times height. So pi 5 squared times 4, and this is 100 pi. In how many different ways can 22 be written as the sum of 3 different prime numbers? That is, determine the number of triples ABC of prime numbers with 1 less than A, less than B, less than C, and ABC adding up to 22. First, let's list the prime numbers, and let's see what kind of combinations we can make. Now, the sum has to be 22, so I think we can stop after 19, because obviously one of the primes can't be greater than 22. Okay, so we got to choose 3 of these guys, and the sum has to be 22. Okay, let's see how many ways we can do this. If I choose 19, then the remaining numbers have to add up to 3, and there's no way of doing that. So I guess I'll choose 17. The remaining numbers would have to add up to 5, and I can do that with a 2 and a 3 from this list. Let's see if there's any other way. Let's try 13. The remaining numbers would have to add up to 9. And how do I do that? 2 and 7 would do it. And I think these are the only ways. So 2 ways is the answer. And I guess the triples would be 2, 3, 17, and 2, 7, 13. Those are the triples, ABC. In the diagram, PADB, TBC, and CD are straight line segments. If TBD is 110 degrees, BCN is 126, and DC is equal to DA, determine the measure of angle PAC. So this is what we know as angle chasing. And let's begin. So where do I go here? Well, if this is a 110, then this has got to be 70, since those two angles have to add up to 180. If that's 126, then that's got to be 54, since 54 plus 126 add up to 180. And then this angle in here, that is going to be 180 minus 70 minus 54, and that's 56. And then, therefore, this angle would be 180 minus 56, which is 124. And then since this shows me that that is an isosceles triangle, these two are the same. So 124 plus 2y is equal to 180, and therefore y, if you do that math, will be 28. And what do they want PAC? What is PAC in this? PAC, this angle in here. Well, that would be 180 minus y, which I believe is 152. So there we go. 152 degrees is the answer to this question. For how many one-digit positive integers k is the product k times 234 divisible by 12? All right. Well, first thing is the 234, I'm going to break up into prime factors. Let me just do it over here so I get an idea. 234, I believe, is 2 times 3 squared times 13. So that's what, 18 times 13? Yeah. Okay. So in order to make this a divisible by 12, we have to divide by 12, and 12 itself in prime factorization is 2 to the power of 2 times 3 to the power of 1. Okay, so let's make a little table. K times 234, and if it's divisible by 12. Yes or no, that kind of thing. Okay, and then the good news is they told me that K is a 1-digit integer, so we have and it's positive, so we have very limited choices, and that's a good thing. So we don't have to go through. So just 1 to 9, and let's see what happens. Okay, so in order for this guy to be divisible by 12, this is always going to work because this is 3 to the power of 2, so it's always going to be divisible by 3 to the power of 1. But in order for this to be divisible by this, we have to add an additional 2. So the K has to have a 2. So yeah, you understand what I mean? Like, let's say K is 2, right? Then you have this 234, which is 2 to the power of 1, 3 to the power of 2, 13. And if you multiply all that, you'll get 2 to the power of 2. And that 2 to the power of 2 then would be able to be divisible by that 2 to the power of 2. So the K has to have a 2. It has to, therefore, be even. So the only even ones are these guys. And yeah, I think that's pretty much it. That would do it. So what are they asking for? How many? So the answer is 1, 2, 3, 4. So 4 is the answer to this question. Points A, B, and C are collinear. That is, lie on the same straight line. What is the value of n? Collinear. All right, well, let's draw a very, very brief graph. 5 minus 8. So somewhere here, I guess. And then 9 minus 30. So we're at 9 minus 30. Way down here somewhere. And then we're going to connect it. And yeah, well, that's not a very straight line, but you guys get the point. So somewhere on here, that's probably terribly drawn, but that's okay. Somewhere on here is C. Now, I don't know where C is, but wherever it is. Okay, so the first thing, of course, is we're going to need the equation of the line, and we have enough information. We have 2 points, so that would be fairly straightforward. Okay, let's do this here. Minus 8 is going to be 5m plus b, and then with the other numbers, we get minus 30 is 9m plus b. Okay, if we subtract these, we will get 9m minus 5m, which is 4m, and then minus 30 minus 8 would give me minus 22. So m is minus 11 over 2. And then if we substitute that back into any one of these guys and solve for b, you will get b equal to 19.5. I know I'm mixing fractions with decimals, but I don't know. Sometimes it's easier to do that. Okay, so now the equation, therefore, is y is equal to minus 5.5x plus 19.5. And then this point C and n is on that line, so substitute n for y and x. So we do that. And then this would be 6.5n is equal to 19.5, and therefore n is 3. So n is 3. So this is the point. So obviously the line, I guess, should have been something like that. Well, even that doesn't look like a straight line, but you guys get the point. The whole option, the whole purpose of this question is to find the value of n, I don't think they care so much about the graph. What is the difference between the largest possible 3-digit positive integer with no repeated digits and the smallest possible 3-digit positive integer with no repeated digits? The largest one was 999, but they're clearly saying that there's no repeated digits, so I can't use 999. So 987, I believe, would be the largest 3-digit number with no repeated digits. Now, the smallest one with no repeated digits, well, the first number cannot be a 0. The 1 is the lowest I can make it. The second one could be 0, though. And then the third digit can't be a 0 or 1 because of the fact that it can't have repeated digits, but 2. So this is the largest, I believe, and this is the smallest. I'm pretty sure about that. So then they want the difference. So 987 minus 102 is 885, and there we go. Determine the number of pairs xy of positive integers for which 0 is less than x less than y and 2x plus 3y is 80. Okay, though only one equation, right? So we got to do some inspection here. Which way do I want to proceed here? Let me solve for y. You can do it either way, and that is going to be like that. And then let's make a table and see what happens. And my hope is that there's going to be some sort of a pattern. Okay, so positive integers. So I guess we start with the smallest one, which is 1. And then we're going to keep substituting into there. So when x is 1, you're going to get 78 divided by 3, which is 26. So there you go. We got 1. Now let's try 2. You get 24.3. Okay, so that's no good because we want integers. These are not 24.3 is not an integer. If you put 3 for x, you get 20. Sorry, this is 25. You get 24.6, not an integer. If you put 4, you get 24. Okay, so I'm pretty sure that the pattern is that every 3 you'll get an integer. So you get one for 7, 10, 13, and so on. So the corresponding values for y are 22. And it goes down by 2. You notice 26, 24, 22, 20, 18. And then the next one is 16, and that gives you 16. But we stop there because of this inequality that x has to be less than y. So let's count how many actually we got that were integers. And it looks like to me like 5. So the answer to this question would be 5. A telephone pole that is 10 meters tall was struck by lightning and broke into 2 pieces. The top piece AB has fallen down. The top of the pole is resting on the ground, but it is still connected to the main pole at B. The pole is still perpendicular to the ground at C. If the angle between AB and the flat ground is 30, how high above the ground is the break? That is, what is the length of BC? Okay, so the pole is 10 meters tall, so that means that this distance and that distance equals 10. So I'll just call that x, and then this will be 10 minus x. And they're saying that's a right angle. And they're saying this is 30 degrees. Okay, so then that means this is 60 degrees. And as you know, for the millionth time, the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. So that basically means that x over 10 minus x, the ratio would be 1 over 2. And that's basically the algebra. So if you cross multiply, you get 2x is equal to 10 minus x, and therefore 10 is equal to 3x, and therefore x is equal to 10 over 3. And I believe that is what they're asking. How high above the ground is the break? And I have denoted that as x. So if a is 2 to the power of 3, b is 3 to the power of 2, evaluate. All right, so let's substitute this in. This is 8, and this is 9. Right? So a minus b would be 8 minus 9 to 2015. And then we got this 1 to the power of 2015, which is just 1. And then we have 8 minus 9 again to 2015, and then this minus 1. Well, 8 minus 9 is minus 1. So minus 1 to the power of 2015. And then minus 1 to 2015, minus 1. Okay, minus 1 to the power of 2015 is minus 1. And therefore, this just becomes 0 after all that. And that's the answer. What is the largest perfect square that can be written as the product of 3 different one-digit positive integers? Okay, so we have a perfect square that's the product. Okay, so we got to multiply 3 of these one-digit numbers. All right, largest. Okay, that's the key thing there. Okay, so if I want the largest, let me start off with the largest one-digit number. The largest one-digit number is 9. And the good news is 9 itself is a perfect square, so that's a very good choice. The next number, the next largest number is 8. So let's see what happens if I put 8. 8 is 2 to the power of 3. But that's not a perfect square. But if I put a 2 here, which is 2 to the power of 1 basically, that would combine with the 2 to the power of 3 to give 2 to the power of 4, which is 16, which is a perfect square. So this is one option. This is 144. Now, you have to see if you can do this again with 3 other one-digit numbers and get a number higher than 144, and the answer is you can't. So 144 is the answer. And you can experiment. You can put 9, you can put 4, and see what happens. A moving sidewalk runs from point A to point B. When the sidewalk is turned off, that is not moving, it takes Mario 90 seconds to walk from point A to point B. It takes Mario 45 seconds to be carried from point A to point B by the moving sidewalk when he is not walking. If his walking speed and the speed of the moving sidewalk are constant, how long does it take him to walk from point A to point B along the moving sidewalk when it is moving? All right, so they want you to figure out 2 speeds and then add them. So the first speed, the formula speed is equal to distance over time, would be d over 90 seconds. And then the second speed, which is, again, d over t, the same distance, but this time it's 45 seconds. So the speed that they're asking is walking on the moving sidewalk. So it's 2 speeds combined, so S1 plus S2. And that's going to be d over 90 plus d over 45. And then multiply by 2. So this 3d over 90, which is d over 30. Okay, but they don't want d, they want t, correct? So speed is equal to distance over time. So we're going to use that as my speed this time. D over 30 is equal to d over t. The d's cancel, so t just becomes 30. So 30 seconds is the answer to the question of how long does it take him to walk from point A to point B when he's walking on the sidewalk that is moving. A square has side lengths s and a diagonal of length s plus 1, right? The area of the square in the form a plus b root c, where a, b, c are positive integers. This is a square. These are the sides. And this diagonal is s plus 1. So by basic Pythagorean theorem, we have s squared plus s squared is equal to s plus 1 squared. And what do they want me to figure out? Area of the square. So the area of the square is s squared. So I guess I have to figure out the numerical value of s. I think, yeah. So, and obviously I'd have to use that equation. Okay, let's do this. So 2s squared is s squared plus 2s plus 1. Let's put everything on one side. S squared minus 2s minus 1 is 0. And I don't think this factors. We have to use the dreaded quadratic equation. It's not so bad. Minus b plus or minus the square root of b squared minus 4ac all over 2a. And that becomes 2 plus or minus, what is that, root 8? Yeah, root 8. And that's 1 plus or minus root 2. Now, s has to be positive, so the only option we have is to choose the plus guy, because the negative one would make it a negative number, and that obviously would not make sense. Okay, now that I have my value for s, I can put it in here. So 1 plus root 2 all squared. And when you do the expansion and collect like terms, you get 3 plus 2 root 2. And that is in the form a plus b root c. In the diagram, determine the number of paths that follow the arrows and spell the word Waterloo. All right. So our end goal is to try to figure out this number here. And it's cumulative, so let me explain. Okay, so how many ways can I get to this A? There's only one way. From the W. W is the starting point, right? So I put 1 here. Similarly, how many ways can I get to that A? There's only one way. So I put a 1 here. Okay. Now, how many ways can I get to this T? Well, there's only one way. This direct path, this, and then this. But how many ways can I get to that T? Okay, that's different. I can get there by first going to this A and then going this way, or I can go first to that A and then going that way. So there's 2. And then that's 1 because it's symmetric on either side. Now, you can keep counting like this, or what you can do, which is sort of a simpler way, is add the preceding row. For example, in order to get this 2, we just added those 2 guys. You see what I mean? And in order to get this guy, you add this and this. So that'd be 3. In order to get that guy, you add this 2 and that 1. So that's 3. It's a little bit easier than to count. Now, these end points are always going to be 1 because there's only one way of getting there, because you cannot go backwards. You can only follow the arrows. And then now it should be fairly straightforward. In order to get that R, you add the 1 and the 3. That's 4. And then that R, you add this 3 and that 3. That's 6. And to get that R, it would be that 3 plus that 1, which is 4. To get this L, it would be this 4 and this 6. That's 10. To get that L, this 6 and that 4. That's 10. And then finally, to get that O, this 10 and that 10. And that gives me 20. So 20 is the answer. For some reason, they keep going to another. Oh, wait. No, there's 2 O's. Okay. I thought that was redundant. Well, there's only one way to go from there to there, so I guess that's 20. Interesting. So the answer to this question is 20. So there's a total of 20 paths based on where the arrows are pointing. What is the measure in degrees of the smaller positive angle x for which 4 sine squared x times 2 cos squared x is equal to 2 the 4th root of 8, if I'm reading that correctly. Okay. So 4 sine squared x and then 2 cos squared x, and then we got 2, and I'm going to write it in terms of a fraction. Just makes it easier for me. That symbol is a square root, but they've put a 4 in there, and basically what it means is 1/4 as the exponent. And of course, you guys know that already. All right, so let's try to make this all the same. So I'll convert that 4 to 2 squared. And then this is already a 2. And then this is 2 to the power 1. 8 is 2 to the power 3. So I think I've got them all in powers of 2. Now let's combine them using exponent laws. This will be 2 sine squared x plus cos squared x, right? And that would be 3 over 4 plus 1, so 7 over 4, I believe. Okay, bases are the same, so that means the exponents are the same. So that means that 2 sine squared x plus cos squared x is 7 over 4. All right, we're getting somewhere. And now I'm going to break up that sine squared x into sine squared x plus sine squared x. And then you guys will notice something. And probably this is the most famous trig identity. There's many, but this is the most famous one in my opinion because it equals 1, and most people do remember that. I actually don't remember all the trig identities because there's so many of them, but this one I remember, so at least that's good. So that just makes this sine squared x plus 1 is 7 over 4. So sine squared x would be 3 over 4. And then we've got, let's see here, what are the smallest positive angle? Okay, smallest positive angle, because there's lots of answers to this. So first let's just make it sine x, and that's going to be root 3 over 2, but it's plus or minus. Let me draw the sine graph. So it's going to look like that, right? And they want the smallest positive angle. So we're just interested in that portion of the x-axis. So I think it's 60. Yeah. There's many. I mean, this, as you know, it goes on forever, right? It just keeps on going. But they want, in particular, the smallest positive angle, and the answer to that would be 60 if you were to look at the values for x that satisfy that equation. If the log of 675 root 3 to the base 3n is equal to the log of 75 to the base n, determine the value of n to the power of 5. Well, the first log rule that we are going to use is the one that says that b to the power of log of k to the base b is equal to k. So we're going to write 3n to the power of the log of 3n 675 root 3 is equal to 3n to the power of log 75 to the base n. And I think, yeah. Well, this is just obvious. I'm just trying to think how. I think this log rule will make this side just 675 root 3. This log rule. But this side doesn't really do much for us. But we can break this up with another log rule where we can break up the 3 times n into 3 and n. So that's perfectly valid using our log rules. Okay, now this log rule can be applied to that. So this side just stays the same for now. And I think this 3 log 75 to the base n stays the same, but this just becomes 75, I believe. Yeah. Okay, good. So let's just see. They want n to the power of 5. So let me just keep that in here. They want n to the power of 5. Okay, now let's divide through by 75. And when we do, we get 9 root 3 is equal to 3 log of 75 to the base n. Okay, and then since everything is to the power of 3, well, I shouldn't say everything, but this side is the power of 3. Let's convert these to 3's. So this is 3 squared, and then the root 3 is 3 to the half. So that would be 3, 2.5, so 5 over 2. There we go. So now we got something where we have the same basis, so the exponents are the same. So 5 over 2 is equal to the log of n 75. So then now it's simple log rules. N to the power of 5 over 275, and then we can square both sides to just get n to the 5, and that's going to be 75 squared, which is 5625. And there we go. That is what we wanted, and that's what we got. What is the roots of x squared plus bx plus c 0 are the square roots. Squares of the roots of x squared minus 5x plus 2 is 0. What is the value of c over b? Okay. Well, the first thing that comes to mind is that Vieta's formula. And Vieta's formula states, and we can just use this guy, that if you have x squared, no, I would have to use ax squared plus bx plus c. If the equation is that, then the sum of the roots, according to Vieta's, is equal to minus b over a. And the product of the roots, is c over a. So let's see what we can get with Vieta's formula and these equations. Okay, so the sum of the roots for this guy, so x squared minus 5x plus 2 is 0. The sum of the roots would be minus b over a, so that's going to be just, I believe, just 5. Now I'll call those roots r1 and r2. And the product of the roots, that's going to be c over a, which is just 2 in this case. So r1 times r2. Okay. Now they're saying that the roots of this guy are the squares of the roots of that guy. So for x squared plus bx plus c is 0, the roots are actually the squares. So it'd be r1 squared and r2 squared. Got it? And, what else do I do now? Well, one thing is for sure, that these two expressions make me think of algebra. And in particular, when you square that, it becomes r1 squared plus 2r1 r2 plus r2 squared, like that. So then that allows me to substitute these numbers, and hopefully that will help me in solving something at least. So r1 plus r2 is 5, so that's 5 squared. r1 squared and r2 squared I'll just group, and then this guy is 2, so that's going to be 2 times 2. So as I had hoped, it does help. So that's going to be 25 minus 4, which is 21. So that's good. That's a good finding, that the sum of those roots, sum of these roots, is 21. Okay, so we're getting somewhere. And then I guess we can use Vieta's again. On this guy, right? So sum of the roots, which would be r1 squared plus r2 squared, is minus b over a. So that would basically be, well, is there an a in here? No, there's no a. This is just 1. So that would just be minus b, I guess. Yeah, minus b over 1. Okay. And then the product of these roots, which would be r1 squared times r2 squared, which would be c over a, would be c over 1. Yeah. Okay. And I think, what are we trying to figure out? C over b. Yeah, c over b. So c over b would be r1 squared times r2 squared over b would be the negative of that. So negative r1 squared plus r2 squared. Okay, well, this guy on the numerator, well, that one we know would be 2 squared. And then the denominator, that sum, I think we just figured out, was 21. So it'd be 4 over 21 negative. Yeah. Okay, so it took a little bit of messing around, I guess, with Vieta's formula. But I'm pretty sure negative 4 over 21 is the answer to the question. Zach has 12 identical looking chocolate eggs. Exactly 3 of the eggs contain a special prize inside. Zach randomly gives 3 of the 12 eggs to each of Vince, Wendy, Zin and Yolanda. What is the probability that only one child will receive an egg that contains a special prize? That is, that all 3 special prizes go to the same child. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And apparently that special prize is only in 3, so let's just assign it to some 3. And then what they're saying is they've got these 4 kids, V, W, X, and Y, and they want all 3 of those prizes to go to the same kid. So let's just say we want them all to go to Vince. So when this is distributed, it'll be like that. And they're saying, what's the probability of that happening? Okay, so let's talk about this. Probability of anything is usually a fraction, unless it's 1. And then top is the specific condition. And the bottom is the total number of cases or total number of ways. So let's talk about this. So let's talk about total first. So from 12, first you're going to choose 3. And then from the remaining 9, you're going to choose 3 to assign to the next kid. Yeah. I think, yeah. And then from the remaining 6, you choose another 3. And then from the remaining 3, you choose the final 3. Zach randomly gives 3 of the 12 eggs to each. Okay, I'm pretty sure that's the total. That's got a huge number, right? But the specific condition is that all 3 go to the same child. So this is one scenario. So that means that we just assigned all 3 of those to Vince, and then we go on with the selection. From the remaining 9, you choose 3 to go to Wendy, and then from the remaining 6, you choose 3, and then from the remaining 3, you choose the final 3. But this can be, the important to remember is this can be done in 4 ways. This is just one of the 4 ways. We could have also assigned all 3 to W or X or Y. So we got to put a 4 out here. And I think this is the answer. The good news is a lot of stuff crosses out. That cancels with that. That cancels with that. That cancels with that. So this just becomes 4 over 12 12 choose 3, which is 220. And then in lowest terms, it's 1 over 55. So interesting question. Define f at x to be x squared over 1 plus x. And suppose that a is f at 1 plus f at 2 all the way to f at 2015, and b is f at 1 at f at a half plus f at 1/3 all the way to f at 1 over 2015. Each sum contains 2015 terms. Determine the value of a and b. Let's figure out a. F at 1, we're going to substitute it all into there. So that looks like 1 over 2. Then f at 2 would be 4 over 5. F at 3 would be 9 over 10, and so on. 16 over... F at 4 would be 16 over 17, and so on. All the way to 2015 squared over 1 plus 2015 squared. Okay, now let's do the same with b. And you might have to do this a little bit on the side. The first one's easy. That's just 1 over 2. But with a half, you might have to, figure this out. Half squared over 1 plus a half squared. So that's 1/4 over 5 over 4, which is 1 over 4 times invert and multiply 4 over 5, which is 1 over 5. So if you need to do that on the side, do it on the side. And then similarly, when you do this, this will be 1 over 10. This will be 1 over 17. And then eventually you get to 1 over 1 plus 2015 squared. Okay, and now they're saying what is a plus b? Okay, so now we're going to add all these guys, a plus b. Okay, well, that and that is 1. That and that is 1. That is 1. You're getting the hang of this. That is 1. And then eventually you'll see that this is also 1. And since there's 2015 terms, you're basically going to be adding 2015 of those ones, which of course is 2015. For each positive integer n, define the point P, n, to have the coordinates n minus 1 squared times n minus 1. And the point Q, n, to have the coordinates n minus 1 squared, n 0. For how many integers n, where n is between 2 and 99 inclusive, is the area of the trapezoid Qn, Pn plus Pn1, Qn plus 1 a perfect square? Well, let me draw something first, and let's do it for n equals 2. And let's see what happens. So if n equals 2, then P2 would be 1, 2. Remember, I'm using these formulas. Pn is this, and Qn is this guy. So Q2 would be 1, 0. P3 would be 4, 6. And Q3 would be 4, 0. I'm just trying to figure this out, like what it looks like. So if I plot these, let's see here, 1, 2. So let me attempt to draw this according to scale. 1, 0, that's this guy. Then 4, 0, so 1, 2, 3, 4 here. And 4, 6. So 1, 2, 3, 4, 5, 6. So, okay, so this is my trapezoid. And yeah, okay, so I got it. But instead of numbers, we've got to use the letters. And then we got to figure out when it's a perfect square. Okay, I think I can approach this with the letters. So the area of the trapezoid, would be, let me label this. I think it'll help if we label it. This was Q2. This is P2, that point right there. And then this one was Q3. And this guy up here was P3. So the area of the trapezoid would be P2 Q2 plus P3 Q3 divided by 2, and then times the height, which in this case would be Q2 times Q3. So what I did was this plus this, and we're making that guy the height. And that's the basic formula of a area. So if you just do it on this guy up here, that would be P2 to Q2 would be, I believe, 2. P3 to Q3 is 6. And then Q2 to Q3 is 3. So this looks like 4 times 3, which is 12. Now, of course, we have to do it for n's. So that is the challenge in this question. Okay, but I think it should be possible. And then there's some parameters, right? That n's got to be between 99 and 2. Okay. And then these are the formulas. So Pn is n minus 1 squared, and then n times n minus 1. And then Qn is n minus 1 squared and 0. Okay, let's do it. So again, this time area, but now we're going to be using the n's. So I think this is perfectly valid. We can keep that constant. So it's going to be n times n minus 1 minus 0 plus n plus 1 times n plus 1 minus 1 minus 0 all over 2. And then, oh, I ran out of space here. Multiply that by Q2, Q3. So that's going to be n plus 1 minus 1 squared minus n minus 1 squared. All right. Okay, let's try to do what here? Simplify, I guess. Okay, so let's simplify. So we get n squared minus n plus n squared plus n over 2. And that's going to be n squared minus 2n plus 1. And let's see, about a whole bunch of stuff here cancels. Okay, oh, that's not as bad as I thought, actually. And we want this to be a perfect square, right? Yeah, we want it to be a perfect square. So we want to figure out what values of n will that be a perfect square between 2 and 99 inclusive. Okay. Well, I guess we have to make a table and see what happens. And I hope we don't have to do them all, because that would be very time consuming. Now, this is already a perfect square, so we just have to figure out when is 2n minus 1 a perfect square. So 2n minus 1. And then, is it a perfect square? Okay, let's see. Well, let's start off with 2. That becomes 3. Is that a perfect square? No. 3, that becomes 5. No. 4, 7. 5 is 9. That is a perfect square. So that is a yes. Okay. So that's not so bad. I just have to figure out which perfect squares are of the form 2n minus 1. And you will see that that holds true for 8. Because that's... actually, no, not for 8. 8 would give you 15. Okay, that's not good. 13. That would be 25. 25 for n would give you 49. That's a perfect square. 41 would give you 81. That's a perfect square. 61 would give you 121. That's a perfect square. And finally, 85 would give you 169, which is a perfect square. So it's, let's see here. Let's circle the ones that worked for n. This guy, this guy, this. So how many are there? 1, 2, 3, 4, 5, 6. So 6 is the answer to this question. In the diagram, triangle PQR is right angled at P and PRQ is theta. A circle with center P is drawn passing through Q. The circle intersects PR at S and QR at T. If QT is 8 and TR is 10, determine the value of cos theta. Let's do some labeling here. First, let's extend this line from that all the way to the end there, like that. And then let's label as much as we can. The S to R, I'll call X. The P to S, well, that's the radius. And then this is also the radius going to the other end. This is also the radius PQ. QT, they told me, is 8. And TR, they told me, is 10. Okay, that's pretty good. And therefore, cos of theta would be PR over QR. And according to what I've labeled, PR is R plus X, where R is the radius, and QR is 18. Yeah. Okay, so I guess we have to figure out the values of R and X. All right. Well, the first thing I think of is Pythagoras on that triangle. R plus X squared plus R squared is 18 squared, right? So that means that we have, well, R plus X would be 18 squared minus R squared, all under the square root sign. That doesn't really help us, but perhaps if we got the value of R, we could just get R plus X and then sub into there. So maybe it's not so bad. Okay, now here's the thing. I knew this question would have some sort of a theorem involved. And usually it's a theorem that I don't remember. And that theorem is the secant theorem. There's so many, right? And in this question, this is the one that you're going to apply. And when you apply it, you do so as follows. It would be that RS times RU, where U is sort of this point at the very end, that is equal to RT times RQ. So that is the secant theorem applied to this question. And subbing in our values, we got X plus 2R, then we have 10 and 18. So that means that X squared plus 2XR is 180. Okay. Then I guess we have to now do some algebra. I'm trying to think how. Let's see here. I think I have to bring this guy back. Yeah. So when I expand that, it'll be r squared plus 2xr plus x squared plus r squared, like that. If you expand this, is 324, correct? But the good news is, well, first let me just group those two. And then this one, 2xr plus x squared is 180. So that's the good news, I guess. And that allows us to solve for r. So 2r squared would be 144. So r squared would be 72. So therefore, we can sub that back into here, that r plus x is 18 squared, which is 224, minus r squared, which is 72. So that is the root of 252. And therefore, cos theta would be the root of 252 all over 18. And that, I believe, is, what is it, 6 root 7? And over 18. So that's going to be root 7 over 3. Suppose that n is a positive integer and that the set S contains exactly n distinct positive integers. If the mean of the elements of S is equal to 2/5 of the largest element of S and is also equal to 7/4 of the smallest element of S, determine the minimal possible value of n. Well, we have some set, and we have the largest guy, and then we have a whole bunch of numbers, and then we have the smallest. The smallest is called P. Okay, and then the mean, let's call that mean equal to M. And the mean is 2/5 of the largest, so 2/5 of L. And the mean is 7/4 of the smallest. So that means that 2/5 L is equal to 7/4 of P. So that means P is equal to 8 over 35 L. And that means that since these are all positive integers, right? The set contains n distinct positive integers. So L is a positive integer, so that means that L is divisible by 35. So that means L is equal to some multiple of 35, so call it 35K. And yeah, so that means if you substitute 35K into there, you'd basically get P equals 8K. Okay, and therefore M, the mean, would be 7/4 of P, which is 7/4 of 8K, which is 14K. So you got everything in terms of K. Now the sum of all these elements, so if you were to add up all these guys, like all of the ones in here, I don't know how many there are. Well, no, we do know how many there are. There's n. There's n elements, and the mean is m. So the sum would be n times m. And therefore, since m is equal to 14k, it would be n times 14k. Yeah. So that is 14 nk. So 14 kn, nk, whatever, has got to be greater than that L plus P. Because there's a bunch of other elements in there. But it could be equal if L and P are the only elements. So, but it's got to be at least equal to or greater than the sum of the elements. Yeah. Okay, so then 14kn, if I substitute the values for L and P in terms of k, would be 35k plus 8k. So that means 14kn is greater than 43k. The k's disappear, therefore n is greater than 43 over 14. Now n is a positive integer, it even tells you that. So that means this has got to be that n has to be greater than or equal to 4. Okay, so what do they want? They want the minimum possible value of n. Minimum possible value of n. Well, let's see. Let's try 4 and then let's take it from there. That is the minimum possible value, but we have to make sure that it actually works. If n is 4, then the sum of the elements would be, where's the sum of the elements guy? Right here. Right here. It would be 14 times n times k, which is what, 56k? Yeah. So we have to see if we can make 4 elements that add up to 56k. Well, this is the largest one, which is L. That's 35k. That's already been predetermined. This is the smallest element. That's P. That's been predetermined to be 8k. Now the sum is 56, so these two guys have to add up to 56 minus 35 minus 8. What is that? 56 minus 43 is 13. So those two have to add up to 13k. But that's not possible because this is the smallest. So this has to be greater than 8k. And there, like for example, it has to be at least 9k. And therefore this has to be at least 10k. And there's no way they're gonna add up to 13k. So it's a contradiction. It falls apart. So that's no good. So that means that's no good. Okay, let's try n equals 5. Let's see if we can make it work. Sum of elements this time. Same thing. It would be using that formula. Be 14 times 5 times k, which is what is that? 70k. Okay. So now let's see if we can find 5 elements that make this work. Well, the largest one is 35k. The smallest one is 8k. So that means these 3 guys have to add up to 70 minus 35 minus 8, which would be 27. Okay, so can we do that? I think so. But they have to be distinct, right? Yeah, they're all distinct. Okay, so I was thinking 999, but they have to be distinct. I can maybe if I make k equals 2, then I could make it work, because then that would be 70. That would be 16, and these would have to 54, and I could put 17, 18, 19. Yeah, there you go. That works. So based on everything I've done, the smallest value of n is 5. A circular cone has vertex I, a base with radius 1, and a slant height of 4. Point A is on the circumference of the base, and point R is on the line segment IA with IR equals 3. Shahed draws the shortest possible path, starting at R, traveling once around the cone and ending at A. If P is the point on this path that is closest to I, what is the length IP? The first thing we have to talk about is opening it up. So let me attempt to draw what I believe it looks like. Let me think about this. So you're going to take a shape like this. It's basically a circle with a segment cut out. So we've cut that segment out. And then and this is the top. So this is my eye. And then when you combine this side with that side, it would become a cone. Yeah. Like that. So I'm going to draw that again, but I'm going to have to label it this time. So basically you're taking a circle. Well, that's not very good. Hold on. Let me try to draw a little bit better here. It's a little bit better there. And then this is the eye, this is the top. And then when you put it together, it becomes a cone. And then I'm going to sort of explain the corresponding elements. So this is the radius. I'll just call it R. But when you combine it, this is what R is. Does that make sense? And then I is the top. So this is I up here. And then the arc length, this whole thing right here, that's arc length. Arc length. We'll just call that A. And in this diagram, it represents this circumference. So circumference is A. So hopefully that makes sense. I hope. Okay, so now we have to do what? We have to fill in the values of what they gave me. So let's see here. They gave me, what did they give me? The only thing they actually gave me was that the slant height is 4. So that means that this guy is 4. This R is 4. So if R is 4, then that means the circumference of this guy is pi times the 2R, which in this case would be 8 pi. Yeah, the circumference of the entire thing would be 8 pi. And the only other piece of information they gave me is that the circular cone has a base radius of 1. So that means this is 1. So if that's 1, then that circumference is going to be 2 pi. But that circumference represents A. So A is 2 pi, where A is this arc length. So that 2 pi is, compared to this 8 pi, is 25%. So that means that arc length is actually only going to be a quarter of the circle. So that 2 pi over 8 pi, since that's a quarter, that arc length in this diagram is way too big. I actually have to draw an arc length that's only 25% of a circle. So like this, where that's the, because the entire circle will be 360, so a quarter would be 90. Does that make sense? Okay, I got it. I think I got it now. Okay, so I have to sort of redraw this diagram here. I've got to do, let me just draw it bigger. Okay, that is how you draw it. Okay, and then the original diagram is there, so I can sort of keep it there and explain this. So this will be my A, and then this I'll call A prime. When you combine it to make the cone, those will join. So both of them are technically A, but I'm just separating them as A and A prime. This shape is when it's flattened out. This is when it's actually been combined to join to make a cone. And then this is I. And then R is here. And this is 3, and this is 1, according to what they told me in the question. And anything else? I got to go from R to A prime. So I'm going to draw a line that goes there. Okay, good. And what else do I know? I know that this is 90 degrees because of that. Because the full circle has 360 degrees. So a quarter of that would be 90 degrees. That's why that's a right angle. And then the question is asking me, there's a point P on the path between R and A prime, and that's closest to I. Okay, so that basically means that P would be a point on that line that if I connected it to I, it would be a 90 degrees. That's how you draw the closest point. So that's P right there. All right, I think, and that's 4, and I think that will do it. Okay, the first thing is using Pythagoras, RA prime will be 5, and most of you can figure that out pretty easily. 3 squared plus 4 squared, take the square root. And then, if you look at that triangle IRA prime, the area, you can figure out 1/2 base times height. You can use 3 as the base, 3 as the base, 4 as the height. And when you do that, you get 6. But you can also figure out the area using 1/2 base times height, where RA prime is the base and PI is the height, correct? So that means you can use RA, which we got as 5, and then this PI, or what are they calling it? IP, PI, same thing. Yeah, IP. And this would give me 12 over 5. And I believe that solves it. So, yeah, a little bit of conceptual imaging here to try to figure out what this thing looks like when it's all opened up, and that will help you figure it out.